add or subtract, and simplify. Assume no variables are equal to 0. You don't have to worry about why that's the case. We'll get into that later. Leave answers as either proper or improper fractions. No mixed numbers. All right, before we, well, actually, all right, so I'm going to start with 7 right here. But I'm going to show how this works with models. Now, if this doesn't make sense and you hate it, then ignore it, okay? But I like to, I said I was going to use brownies, right? So it's like saying we got 2 pans of brownies. Second one stung. There we go. And the first pan has 3/8 of brownies, right? 1, 2, 3, 4, 5, 6, 7. And these parts are not there, so we only have 3 of those parts. So the dashed lines indicate that there would be pieces there, and yes, I'm sorry, they should be the same size, but sorry, I'm not perfect yet. Anyways, the next pan would be divided into sixths. So 1, 2, 3, 4, 5, 6, and of course, we've only got 1 piece in this pan. So the question is, if I combine these, how much of a pan of brownies would I have? Now sometimes when we add these, we end up with more than 1 pan, which is a mixed number, and that's okay. But here's what we have to do, is we have to divide these up so that they're the same size pieces. So for example, I gotta bring these lines down from the top one, and that divides this up into equal size pieces. But if I did it to this pan, I should do it to the other one. So 1, 2, 3, 4, 5. And now we're comparing the same size pieces. Of course, that would be the case if I drew it correctly. Now again, if you hate this, ignore it. We'll get into the actual math of it here, okay? So right here I have this row of, that's a row of 1, 2, 3, 4, 5, 6. 2 rows of 6, 3 rows of 6, and this is a row of 8 now. So in terms of how many pieces I have, I got 18 plus the 8, that's 26 pieces. But the question is how big are the pieces? Well, in terms of the pan was going to fit 6 here and 8 there, which was 48 pieces. Now this can be simplified, which may make this a little bit more confusing. But again, I'll get into the math of it here in a second. So that would be 13 out of 24 pieces. So you have 13 pieces that are the size of a 24th of a pan. Well, again, if you hated that, let's look at this more in terms of the math. So 3/8 plus 1/6. That model is really just to demonstrate why we need common denominators, because we need to compare the same size pieces if we're going to combine them, okay? Even if we're going to eat them. If this was subtraction, we would be eating, I guess however many pieces that is. So let's find common denominators first. So again, we can list these. I got 8, 16, 24, 24. Yeah, I did that right. Yeah, 24 should work. So 6, 12, 18, 24. So the 8, I'm going to multiply that by 3. So I'll multiply the 3 by 3. So that gives us 9 24ths. And then the 6, I multiply that by 4. Again, that's to get 24ths. So I got 24ths here. 1 times 4 is 4. And what this allows us to do is it allows us to create one big fraction right here. Now, not everyone needs this step, but I like to show it because it really specifies what happens with the fractions. And we can go either direction in this case. We still have the 9 plus the 4 here. See, because we're comparing the same size pieces. So this ends up being 9 plus 4 is 13. and we had the denominator, which was common, 24. So that's what we got up here. That's what we get right there. So I'm going to ignore the models, so that hopefully this will make a little bit more sense. I got 14, and again, we want a common multiple of each. 14, 28, 42, that sounds good. 21, 42, there we go. So 14 would have to multiply that by 3 to get 42, which means I'm going to need to multiply the 9 as well. So 3 times 9 is 27, 3 times 14, that's what we wanted, 42. And this is subtraction this time. 21, we'd multiply that by 2, so 20 by 2 as well, giving us 40 seconds. Now again, this step is only to help us not get confused with what is happening with the denominators. We have common denominators, so we're going to keep that denominator common. And I'm going to take the 27 and I'm going to subtract 40. Well, 27 minus 40 is negative 13 over 42. And looks like, yeah, it's not divisible. 42 is not divisible by 13. Yeah, so this would be our final answer. So I was just checking to see if that was simplifiable, but it's not. Number 1, this one already gave us common denominator, so we'll just keep it there. But we do have the negative 2 plus 1, which would be negative 1/5. So those are pretty nice when they give us those common denominators. So this one again, common denominator of 8, and the numerator 7 minus 5, which is 2/8. This can be simplified by dividing both these by 2, and this ends up being 1/4. But the nice thing about 6 is they gave us the common denominator of 11. So we can rewrite everything in the numerator, negative 2z plus 3z minus 7. So we have to be careful and go back to, I think it was module 1, where we were just looking to combine like terms. And to do that, we'll keep the 11 there, but these two like terms we can combine. And that's in terms of z's. Negative 2 plus 3 is 1. Then we just have that subtract 7. So this would be as simplified as we can make this thing. Some people really like, let's show that, if we have that common denominator, as it turns out, we could split the fraction up. I just don't know that it really simplifies anything. 1z over 11 minus 7 over 11. So it is possible to split that up because we have the same denominator. It's like doing what we did in the beginning, but we've reversed it at the end. So this one did not give us a denominator for that negative 5x, but it's there. It's just kind of a phantom one kind of thing. So we can see that the 1, I mean, we can find multiples of 1, but eventually we'll just get to 10 anyways. So, I mean, I have to multiply that by 10 to get a common denominator. So I have to multiply the negative 5 by 10 as well. So this gives us negative 50x over 10, and we'll add this to the 3x over 10. So we have our common denominators, 10, and we'll just write this out, negative 50x. Again, you may just be doing this without this step, and that's okay, plus the 3x, because some of you just know I've got common denominators. I can combine the 50x and the negative 50x and the 3x. Again, that's all a matter of preference. So over 10, I got negative 50x plus the 3x's would give us negative 47x's. Bam. So on this one, see how we got that minus negative stuff? I don't really like to see minus negatives. So the negative tells us we'll do the opposite of minus, which is plus. But it just takes care of that negative as well. So I'm going to add these. And so I have that common denominator of 18. I got x plus 5x. We have to remember as well that the coefficient of that just single x is 1, it's 1x. So when we combine this, 1x plus 5x is 6x over our denominator 18. 6 and 18 are divisible by 3. Oh, actually 6. So that should simplify it a little bit faster. If we divide both these by 6, we get 1x over 3. Some people are real picky and they'd hate to see that 1, so x over 3 or 1x over 3 would work.